Now let's take a look at something called the binomial theorem. The binomial theorem pops up all over the place in mathematics, and this portion right in here may look familiar to you if you've studied binomial random variables before, but here's what it says. If a and b are real numbers, they can be positive, negative, whatever, and n is a non-negative integer, then you can express the sum of a and b raised to the power of n as the sum, k goes from 0 to n, of, look at this, that's n choose k, we just studied that. In fact, sometimes instead of calling that n choose k, we call that the binomial coefficient. Okay, these are binomial coefficients. So it's n choose k times a to the k times b to the n minus k. Let's do an example to see that it actually works. Suppose we let a equal 6, b equal -2, and n equals, I don't know, say 3. Let's see, so what is a plus b, right, raised to the n? That's going to be, let's see, 6 plus -2 is 4. That's 4 to the third. 4 to the third is 64, right? This is the left-hand side, right? The left-hand side is this stuff here, and the right-hand side is this stuff over here. So let's check to see that they're the same in this case. N is 3, so I got, let's see, I start with k equals 0, so it's going to be 3 choose 0 times 6 to the, 0, times -2 to the 3 minus 0, and then plus 3 choose 1 times 6 to the first times -2 to the 3 minus 1, that's a negative sign, and then plus 3 choose 2 times 6 to the 2th times -2 to the 3 minus 2, plus finally 3 choose 3 times 6 to the 3, right, like so. Hopefully I did all that right. This is the right hand side. What's 3 choose 0? Well, you can do it in your calculator or whatever, but I know that it's 1. That's because there's only one way to choose no things from 3 things. There's only one way to do nothing. Actually, that's not true. I've invented all kinds of ways to do nothing, but that's another story. So 3 choose 0 is 1. If you don't believe it, follow the formula. That's 3 factorial, right, over 0 factorial times 3 minus 0 factorial. Oh, this is 1. This is 3 factorial under 3 factorial, so it's just 1. Yep, so sure enough. So this is just going to be 1 times, now 6 to the 0, okay, that's also 1, and then times -2 to the, so this is just to the third power, -2 to the third is -8, and then plus 3 choose 1. How many ways can you choose one thing from 3 things? Follow the formula or just reason through it. It's 3, right? It's just 3 ways. 6 to the first is 6, and we get a 2 up here in the exponent, so -2 squared is +4, and now 3 choose 2. Oh, guess what? 3 choose 2 is the same as 3 choose 1. I know this because it turns out that n choose k is always equal to n choose n minus k. Why is that? Well, if you think about, you've got yourself over here, and your friend is over here. Okay, you've got a bunch of things over here, and you want to share with your friend, but you're going to give your friend, k of your n things, and keep n minus k for yourself. Well, think of it this way: every choice of k things for your friend results in a distinct set of k items for yourself. So they should be the same. And in fact, if you look at the formula for n choose k, you'll see that indeed they really are. 3 choose 2 must also be 3, and then times 6 squared is 36, and then times, let's see, this is 3 minus 2 is 1, so that's going to be a -2, and then finally 3 choose 3, that's got to be the same as 3 choose 0, right, by the same type of reasoning we just had. And 6 to the third, let's see, that's 36, right, times 6, right, 36 times 6, that's 216, and then times, let's see, 3 minus 3 is 0. This raised to the 0 is just a 1 again. Okay, so what is all that? It's going to be -8 plus, this is 3 times 4 is 12 times 6 is 72. And then minus 6 times 36, oh, that's 216. And then plus 216. And what does that spell? Let's see, these go away. 72 minus 8 is 64. Yes, indeed, they are the same.